Hi, and welcome to Stephan Livera podcast, a show about Bitcoin and Austrian economics, brought to you by Swan Bitcoin. Today for episode 482, my guest is Burak. He is a Bitcoin researcher and developer, and he joins me to talk about Arc. It's a new protocol for Bitcoin scaling and privacy. Now, we get into a lot of details on this one. Now, fair warning, this is a more technical episode. Of course, I do my best to try and break it down and put it into simple terms, but just so you know, it is a more technical show, and so we get into some more details around this. We talk about the downsides of Lightning Network, a high-level overview of Arc, ASPs, vTXOs, as well as some of the criticisms. Is it Vapourware? As well as talking about the interactive and non-interactive versions, and also covenants and what they would mean for Bitcoin. Now, as I mentioned, this show is brought to you by Swan.com. Swan.com and the Swan app are great for safe and easy Bitcoin buys. You can do recurring purchase plans. You can do one-time buys. Swan offers free custody in your own legally owned trust account, as well as free automated withdrawals. Now, many people know Swan for the DCA or auto DCA feature, but Swan is also available for people who are high net worth investors and they need a trusted partner. It's also available for those of you in or running a business who want to future-proof your business, your nonprofit, or trust with Bitcoin Treasury services. Swan also offers an IRA product for those of you in the US. So to sign up for all of these, go over to swan.com. Before I send an on-chain transaction, I check out mempool.space. Mempool.space is the leading Bitcoin explorer covering the multi-layer ecosystem of Bitcoin. You can see all kinds of things, whether it's the mempool, the blockchain, second-layer networks like the Lightning Network, and with mempool.space, you don't have to trust a third party. It's free and open source software. And of course, you might have heard the announcement, mempool.space are coming out with a transaction accelerator. So keep an eye out for more details here. And of course, if you are with an enterprise, mempool.space has custom mempool instances and custom features available. So go and find out more at mempool.space/enterprise. Now, as we all know in Bitcoin, it's not your keys, not your coins. CoinKite.com are helping us with all kinds of hardware products and accessories that we can use to secure our coins. So you need to think about your Bitcoin security. Don't leave your coins with an exchange or with a custodian if you are able to take them out into self-custody. CoinKite make the Cold Card, which is the latest version. The Mark IV has 2 secure elements. It has NFC support, and it's a very reliable performer. You can use it in a range of setups and configurations, and actually you'll end up learning a bit more about Bitcoin as you learn how to use those different features. So CoinKite have a range of products. The Mark IV is the latest and greatest. Of course, they have the Q1 coming out later in the year with QR support. And for those of you looking for a cheaper device, try the Tap Signer. This is a credit card sized device. It has NFC support and you can use it easily with wallets such as Nunchuck or Sparrow with the attachment. So go to coinkite.com and get a discount on your cold cards with the code Livera. And now onto the show with Burak. Burak, welcome to the show.
Oh, yeah. Thank you for having me. It's exciting, huh? Exciting times ahead. How's it going?
Yeah, for sure. So I saw you recently announced Arc at the Bitcoin conference in Miami 2023. Mm-hmm. And I know you did do a talk about it previously at BTC++, and you've been talking about it in previous, let's say, iterations, I guess previously known as TBDXXX. Yeah. So do you want to just start with a little bit about what got you here? And I guess you were talking about some of the issues that you saw with Lightning that caused you to actually try and create this. So do you want to elaborate a little bit on that?
Yeah, sure. So maybe to give a bit of a story of myself. I started initially in a big blocker sort of camp, like big blockers camp. Later I got introduced to Bitcoin through Liquid. And then I did some covenant research and development for about 2 years. And recently I started to shift my focus to Lightning about a year ago. I shifted my focus to Lightning. The more I explore the Lightning, the more I realize, well, there are certain problems there. I mean, I've always obviously had objections to Lightning, my objections were centered around the UX, the end user UX hurdles, the onboarding and the entry barrier to onboarding, from inbound liquidity to interactivity requirements, and to async receiving and all that. And I wanted to address these problems because I'm obsessed with UX. I'm obsessed with Bitcoin scaling and privacy too. So I really wanted to address these problems. And I've, because to me, like, if really something works like 95% of the time, it doesn't really work. It has to be like frictionless. And from what I've learned, like, over the past few years, like, people are lazy. Like, people do not want to manage liquidity. They don't want to, self-host the Lightning node. It just has to be frictionless. Like, should just be a piece of software you download, just like an on-chain wallet. Just like an on-chain wallet UX. You have an address, you should just get paid from that address. You can pay from someone in front of you, like to their address. Should be as seamless as on-chain UX. The ideal UX should be as convenient as an on-chain wallet. Unlike Lightning, in Lightning, while we have invoices, you have to be online to receive. You ideally have to self-host. You have to make sure that you have enough inbound liquidity to receive payments. You have to take care of your management, rebalancing, splicing and all that. Yeah, you have to acquire liquidity in the first place to receive like a payment protocol. So Lightning is a protocol. It's the only layer 2 we have on Bitcoin. Yes, it's great. And layer 2 by definition is like it's a piece of different software. You transact Bitcoin off the chain without polluting on chain. You can unilaterally exit on-chain at any time. By that definition, Lightning is the only layer 2, but it has its own problems, complications. For the end users, it just has to be frictionless. And that's what I try to do. Like, that's what I try to address in the first place, like to address these UX problems. And so I realize
what would you say? So just while we're here, what would you say to, let's say, that, as I'm sure you have seen, obviously, I'm sure you're looking at the space, that there have been some pretty big improvements over time, at least. If we compare Lightning in 2018 and 2019 to Lightning today in 2023, there are at least consumer-grade wallets and things, as an example, things like Phoenix or Breeze or things like this that at least smooth over some of those aspects for the consumer level. What would you say about those? Would you say it's still not good enough in your view in terms of the reliability or the async receiving capabilities?
It's not about being good enough or not. It's about like being proper. Like, it's about being like, it's like, to me, like, it's a binary option. It's like either works or not, and it's just now middle ground. They're like improvement. Well, we're seeing improvements. Yes, Lightning can be improved. Yes, with PTLCs, and for instance. With PTLCs, you can tackle the off-chain receiving problem, like offline receiving problem and proof of payment problem at the same time. But you still have this fundamental problem of inbound liquidity, which no problem, no solution can solve. To me, like, it's a bug, like it's a fundamental issue. Lightning is a protocol, like it's a network of payment channels, and it is fundamentally constrained by liquidity deployed on these channels. So, like, I don't see like how you can improve on that. What you can do is like you can do submarine swaps and all that, and some Lightning wallets we've seen, like, who claims to be non-custodial, are based on this submarine swap model, but it's inherently unscalable. They're trading off the convenience versus on-chain footprint, which might work in a short term, like in a short term, but it's going to blow up. And we're seeing that right with recent incidents like ordinal craze, fee market. Because Lightning is a layer 2 because Lightning heavily relies on the base layer to operate. Is heavily reliant on the fee market, and if fee market if the fee market goes crazy, it makes, and in fact it made, we've seen the key Lightning infra unreliable, and so that it has to be just properly set. Like, it has to be well taught, and it has to be frictionless, yet should be footprint minimal. In fact, like, we're not seeing an increase in, I think, like, when you see the Maple.space data, like, we're not seeing an increase in number of Lightning nodes. Especially after this year, like 2023, since the beginning of 2023, we're seeing, in fact, the opposite, a spike in custodial Lightning usage. When you look at like top 10 custodial Lightning wallets, download statistics, App Store and Play Store, we're seeing a spike. Because I think it plays, Nostr and Zaps, they play a huge role in this, because they highly incentivize the custodial UX, custodial preference, because custodial wallet UX is the only UX we have, like, is the only Lightning UX that can work, because of the mainly because of the entry barrier to onboarding. So that's the main problem Lightning faces, right? Like, you need money to receive money, and in order to onboard the system, you need money. Like, you need inbound liquidity. So I orange peel you IE for the first time, and if I want to send you some sats over Lightning, I simply can't, because you don't have any channel in the first place, and you have to, for some reason, like somehow you have to acquire liquidity, like in the first place. And it's not only like not convenient, it also doesn't really scale. both in terms of footprint and in terms of liquidity allocation. Like inbound liquidity do not scale to entire planet. And I know that might sound an utopic idea, right? Like onboarding the whole planet in a non-custodial way. In the end, we'll probably end up having like spectrum of solutions from full custody and to the custody, maybe some like federations and in the middle. Realistically, but at least I think we should give entire planet an option, the self-custody option. The option at least should be there. It should be available to people. But I don't see that option today. Like I don't see a way of Lightning achieving that with its current form, and in fact, in any kind of its future form, because it's fundamentally constrained by inbound liquidity. That's what I wanted to address in the first place. Like on Arc, and in fact, it started as a Lightning wallet idea. So I wanted to address these problems, especially the inbound liquidity. And the initial idea was, I wanted to build a Lightning wallet. Not to solve I try to address mainly the offline receiving problem and the footprint. Like we can tackle the non-interactivity, like interactivity issue, i.e. using like one directional, like unidirectional channels. So when you have like a unidirectional setup, channel setup, all channel states are always in your favor, so that you don't have to be online to sign for channel breaches and all that. And we can tackle the on-chain footprint using like a shared vTXO model with CTB style or N-of-N multisig style. But I really couldn't find a cure, for the inbound liquidity. And I think it's like a fundamental problem of Lightning. Lightning, I think it works great for vendors because like if you're a vendor, your cash inflows are predictable, right? You demand instant settlement, and you can run a specialized software in a POS terminal or something, BT space server, right? It's okay. But if you're an end user, you just don't. It's unpredictable. Like how much you're getting paid is unpredictable. You sometimes receive zaps, donations, remittances. It's highly unpredictable, and you simply cannot acquire liquidity. like it's just not convenient, right? And that's what Arc tries to address. It makes the end user UX frictionless, friction-free. There are trade-offs, certainly. I think we'll come to that. But it offloads complexity from end users to the service providers. So on Lightning, like it's a channel setup. It's me and my channel partner, and we are equally responsible, right, for the liquidity. Me and my channel partner, we're equally responsible for liquidity, for managing liquidity, for making sure, at least from my standpoint, making sure that if me having enough inbound liquidity to receive. But on Arc offloads my complexity on my end, on my edge of channel, right, on my end, into the service provider. So service provider's job is like my service provider is akin to my channel partner, right? It's kind of a channel design too. It has similarities with Lightning, Arc. So it offloads complexity into my channel partner, and channel partner's job is like 10x more difficult now. Like my channel partner has to do more liquidity allocation and all that. But in exchange, for my convenience, I do not have to take care of anything. Like I can receive without a second thought. Just like how an on-chain wallet, how on-chain funds flow, just like how on-chain wallet works.
Okay, so let me just summarize a little bit there because there's a lot in that. So as you were saying, I think the main criticisms you have, like fundamentally, the main criticism you have is the one of inbound liquidity, right? In Lightning, you need somebody to open a channel in your direction, or in some cases you might open a channel and make payments, and now you've got inbound liquidity. But I think the point you're trying to make is that in terms of scaling that and having lots of people have inbound liquidity, maybe there's a capital requirement problem there. Now, I guess the Lightning Bull answer would be, oh, look, there's LSPs to do that, Lightning Service Providers. But I think part of what you're saying is this idea that having a different protocol might smooth the user experience. I think that's essentially the argument you're making, which is that by having this new protocol, Arc, which we're going to talk about in more detail, basically it allows people to receive without first having inbound liquidity. Or having to have an LSP open a channel to you. But there are other trade-offs associated, right? It's not a free lunch. There is no free lunch, but we would be using an ASP instead of an LSP in this example, right? So do you want to just explain a little bit, let's try to keep it accessible for people, as accessible as we can. Can you give us like a high-level explanation of Arc and how it works for people?
Yeah. So guys, ARC is a layer 2, just like Lightning. It's an off-chain protocol. You move Bitcoin, just like Lightning, off the chain without polluting on-chain. In a privacy-preserving way, it does a bit of a better job compared to Lightning in terms of privacy, but it scales Bitcoin transactions off the chain. It's a Bitcoin scaling layer, right? It's a scaling protocol. You move Bitcoin, just like Lightning, but in a better UX. You have a better UX, like I would say 10x. It's Lightning, but with a better, like 10x better UX for end users, and it's interoperable with Lightning too. And in fact, ARC feels like a subnet of Lightning, although it's a separate, distinct protocol. Like ARC is a distinct layer 2, right? ARC is a layer 2. Lightning is a layer 2. Lightning is the only layer 2 we have on Bitcoin. ARC is the second. Like there is no third. I mean, obviously today there is no second. When ARC is there, once we ship ARC, I guess we'll come to that in a second. But once ARC is there, right, on mainnet rollout, after mainnet rollout, if it's there, like there is no third. I mean, assuming that we don't have simplicity, nothing like rollups, there is Lightning and there is ARC. ARC is a layer 2. It's a distinct layer 2, just like Lightning. You move Bitcoin within this protocol without introducing inbound liquidity problems, assumptions, UX assumptions, without introducing, hopefully, non-interactivity. Assuming we have covenants, I guess we'll come to that in a second also, and also preserving the receiver privacy. So ARC does what Lightning does, but better for end users. There are trade-offs, obviously. But ARC is a liquidity network similar to Lightning. So it has similarities with Lightning. So just like Lightning, you have liquidity providers, aka service providers. On Lightning, we call them Lightning service providers. It's a hub and spoke model. There's central hubs on Lightning. There are also some small scale routers on Lightning too. Same goes to ARC too. But ARC can ideally have, in order for the ARC to work really and scale liquidity to the entire planet, we should ideally have smaller hubs, but federated ones, like less but federated instead of more, but single sig. So we have liquidity providers, service providers. We have service providers just like Lightning. Service providers provide liquidity just like Lightning, and they charge liquidity fees just like Lightning. So it has a bunch of similarities. And ARC is ARC is not a state channel design. It's not rollup either. It is kind of its own category. I don't know what the category for this should be. It is a distinct layer 2 with a distinct design. It's like a recipe from different sort of ingredients, but it's not a state chain. It is, I don't know what would the category, what category could this be? I've no idea. But it has similarities with Lightning. It has similarities with eCash. It has similarities with CoinJoin. It has similarities with Wabi-Sabi, the on-chain, and into side chains too, right?
Okay. So let's just try to walk through some a simple. I guess I'm gonna explain how I'm understanding it in a simple way, and then you tell me what did I get wrong or what to add to that. So as I understand, the user in this case he might have some on-chain Bitcoin and he wants to put it into ARC, and he goes to an ASP and he's creating vTXOs, like virtual TXOs, virtual outputs, and we can trade them all around in using the ASP. And then the important point, as you mentioned, is that the user can unilaterally exit, right? He doesn't have to ask the ASP for his coins back. He can just unilaterally take them back after, I think, a 24-hour window. And so, as I'm understanding, it's sort of each round, it's like a round-based mechanism where it's sort of like a coin join, and there's continual transactions going to sort of advance the rounds forward. But there's also a time lock aspect where if you put your coin into an ASP or into a vTXO, there's a 4-week timeout where your wallet needs to come online to refresh, or otherwise the ASP can take your coin, basically. But is that kind of a high level understanding there?
That's quite an accurate explanation. So I think the best analogy would be a sidechain analogy. So you can think of ARC as a sidechain, a trustless one, a trustless two-apex sidechain. I know sidechains are a different category. I mean, because we don't have trusted sidechains, we have merge mined and federated ones. But the better analogy would be, positioning Arc as a sidechain, a trustless two-way peg sidechain. So it's like a piece of software you can peg in and you can peg out.
Gotcha. Yeah.
You trustlessly peg in, and you peg in with your real UTXO. Let's say you possess a set of UTXOs on your cold storage or hot wallet. They're on-chain funds. You have on-chain UTXOs, and you want to peg in, and you peg in through a process called lifting. It's a buzzword, but you basically lift your UTXOs off the chain by depositing your UTXO to a script. We call it an ATLC script, Anchor Time Contract script. But the better analogy would be here like depositing to a 2 of 2 multisig, because it's also 2 of 2. Arc is similar to Lightning on that. Like, you peg in to Arc with your real UTXOs by simply funding a Bitcoin address. And the Bitcoin address is a 2 of 2. Just like Lightning, just like how you open a Lightning channel, you fund a 2 of 2, but this is a special type of 2 of 2. And once you fund that 2 of 2, and that 2 of 2 is between you, right, the user, and the service provider, just like Lightning. It's like a channel, yeah. And from there, you're in the system. And once you're in the system, you have a virtual UTXO. That 2 of 2 is a virtual UTXO, right? You funded that vTXO with your actual Bitcoin. And you have a vTXO, you're in the system. So far, we polluted on-chain, right? By making an on-chain transaction, by funding this vTXO on-chain. But further steps from here are minimal, footprint minimal. Everything takes place in a coin join, like an off-chain coin join, in rapid off-chain coin join rounds. So I have a vTXO. I can have a bunch of vTXOs. There are other people, other protocol users. They also have their vTXOs. They can either acquire vTXOs from exchanges, from a friend, from someone, a third party, or they can directly peg in to the protocol with their own UTXOs. It's up to them. So I have vTXO, and we call it a vTXO set, just like a UTXO set. And you have a piece of software, right? A wallet, a client, an Arc wallet. And you have a set of vTXOs. There are other people, they could use different wallets, different softwares, different Arc compatible wallets. They have their own vTXOs. And when you make a payment, like when you make a transfer, you coin select, just like how an on-chain wallet works, right? It's like an on-chain wallet. You coin select your vTXOs, and you join a coin join round. But this coin join is weird, right? This coin join doesn't have hundreds of inputs, hundreds of outputs. This coin join is weird in that it only has like 1 input and like 3 output. And you are not supplying your vTXOs as inputs to this coin join because they are not on-chain. Like, you can only supply on-chain funds during a Bitcoin transaction. But vTXOs, they live off the chain. Right? You cannot supply funds to a coin join, an on-chain transaction. So what happens is you redeem your vTXOs in exchange for the service provider to provide funds to their own coin join transaction. And this coin join transaction is like 5 inputs, and these inputs are provided by, again, the service provider. And they provide inputs in exchange for redemptions at a later point. Just like eCash, right? Like, they're like, eCash tokens are like short-lived nodes, right? And when you make a payment in eCash, you redeem your tokens in exchange for a Lightning payment. It's very similar. You redeem your tokens, in this case vTXOs, in exchange for a coin join, right? In exchange for the service provider to provide their own money, their own on-chain funds to a coin join. And they can claim it at a later point on-chain. My funds at a later point after 4 weeks. So the inputs are minimal, right? Inputs are provided by the service provider, 1 or more inputs. So this is an actual Bitcoin transaction, right? This coin join. It was like 1 or more inputs and 3 outputs. So output, like output, the first output is a shared UTXO. So that's how, like, that's what makes ORC like ORC. Like, it's based on a shared UTXO model. And this shared UTXO, perhaps some of you are familiar with coin pool, channel factories, and all that. So it's just like how a coin pool works, right? It's a shared UTXO model. You have it's like you have a single UTXO, and you have a bunch of outputs that nests in that UTXO. In a high level, you have a transaction output, and you constrain the descendant of the transaction output, like the subsequent transaction, spending transaction from the output. You constrain the outputs of that transaction in advance of funding the output. So that's what covenants are. Covenants are a way to constrain outputs of a spending transaction in advance of funding a Bitcoin output. And these outputs are the vTXOs. And they're kind of like aggregating, batching a bunch of vTXOs under a shared UTXO, which can be revealed at a later point. You can reveal them on-chain if you want to. Like, covenants give you that assurance, in a scripting level. You can reveal outputs at a later point, but you don't have to. And you do it only in a dispute resolution case, just like a forced closure on Lightning. So that you have a coin join with 5 inputs, like 3 outputs. Forget about the rest. You have like one output as a shared UTXO, and that shared UTXO contains the intended the vTXO of the intended recipient, among other recipients, and you are redeeming your vTXO in exchange for the vTXO of the intended recipient, and the inputs to fund the shared UTXO are provided by the service provider.
I see. And so can we talk a little bit, is there like a change output here, or is it more just like, as an example, let's say I quote unquote peg in, I don't know, 10 million sats, just as an example, and I make an ARC payment to you for 2 million sats. Is it sort of like my balance, let's say my quote unquote balance with the ASP goes down to 8 million sats because I've made a 2 million payment to you, and as part of the ASP, so the ASP is kind of helping me manage that shared UTXO. And because I've paid out, let's say, 2 million sats to you, now my new balance is 8 million sats, something like that. But we're using covenants to sort of restrain the outputs.
Yeah, of course. Like, so if you have like 10 million sats, you have like 10 coins, like 10 vTXOs, each 1 million, right? Each 1 million worth 10 UTXOs, 10 vTXOs. And if you're sending 2 million sats, you coin select 2 vTXOs, each worth 2 million, each worth 1 million, right? You coin select 2 vTXOs, again, each worth 1 mil. You join a coin join, you register for your vTXOs, and then you register for the outputs of the intended recipients, right? And this is based on the public key. Like, you know the public key of the intended recipient already. It's like a silent payment style. But maybe we can come to that in a second. But you join a coin join, you coin select 2 inputs, each 1 mil, and then you register for the outputs of the intended recipient. And then in the third phase, it's just like a coin join, like it's in 3 phases: input registration, output registration, and the signing phase. In the first phase, we register for the vTXOs we are spending. In the second phase, we're registering for the vTXOs of the intended recipients, which goes under the shared UTXO. And then in the third phase, we sign, and we call it anchor. We anchor or coins, like 2 coins we coin selected into the coin join transaction using ATLCs. So ATLCs is the magic. Like it's how we ensure the atomicity here, like the atomicity between my coin, my 2 coin, each 1 mil, and the coin join transaction. And ATLCs are based on TX locks. So TX lock is it is a new kind of primitive I made up. You're probably familiar with TX and hash locks and time locks, right? Hash lock is a condition in which you satisfy preimage against this hash. Time lock is you satisfy the current time, existing time against the predefined timeout. In a TX lock, you satisfy Bitcoin script against predefined transaction ID. So in order to satisfy Bitcoin scripts, you have to prove the Bitcoin script that a particular transaction ID exists. And in the ARC context, when in the anchoring phase, right, in the third coin join phase, when I do the anchoring stuff, anchoring my 2 coins, right, each 1 mil into the coin join transaction, I sign a TX lock from my ATLCs. So, we have like 2 coins. They're like lightning channels, right? We made this analogy. We have 2 coins.
Yeah.
They're each one of these coins are 2 of 2, just like a lightning channel. And just like in a lightning channel, you attach HTLCs to a channel, right? You attach HTLCs to a 2 of 2 channel. In ARC, you attach ATLCs to each coin. And in this ARC context, it is like a channel. It's a 2 of 2. I attach ATLCs to my 2 of 2 coin vTXO, and from there, I form a TX lock between my ATLC and the coin join transaction. And the TX lock, in order for the ATLC to be claimed by the service provider, the transaction ID of the coin join transaction has to exist. If there is a double spend, right, I anchored my coins, ATLCs, into coin join transaction because it contains the coin join contains my intended recipient, right? I want this transaction to be confirmed. If it's double spend in a mempool level, right, you cannot, as the service provider, cannot claim my ATLC, aka attached HTLCs. In order for them to be claimed, the transaction ID of the coin join has to exist. It has to be confirmed, so that it creates an atomic single hop payment schedule from sender to the recipient, and the service provider in the middle.
Okay, so one point I'm not quite following there is you're saying the transaction has to exist, and this part, is that the part where the ASP has to regularly do on-chain transactions to keep the protocol running?
No, that's not that. So
that's another thing. Okay, so can you explain what's the point about the transaction has to exist?
Yeah, transaction has to exist. ASP has to make sure that it exists, and it should should take care of fee bumping and all that to make sure that it exists. Because if it's not, you cannot claim the funds. You cannot the recipient's funds.
When we're talking about transaction has to exist, do we mean like my peg in, or what transaction are we talking about here?
It's not peg in. So we are already in the system, right?
Right, we're already in, and this is talking about vTXOs moving from one person to another inside the ASP ARC system.
We destroy vTXOs, we create new vTXOs. We destroy coins, we create new coins. Just like how on-chain funds flow.
Yeah.
And that takes place in a coin. Yeah.
Okay. And so then, I guess one other question around receiving, like obviously today when we're doing Lightning, I say, hey, Burak, give me a Lightning invoice and I'm going to pay you, etc. How would it work in an ARC context? As I understand, you have just it's like having one address.
Yeah. It's just, if you're familiar with silent payment, it's a silent payment style construction. So you have an address from which you can get paid and you can pay to, right? You can add that address to your Twitter tipping. You can send it to friends and family. It's reusable forever, and it doesn't violate the privacy. There is no address reuse, although it's a dedicated address. And it's going to be your NPUB in the ARC context. So it's going to be your NPUB. It's going to be like WhatsApp UX. You have like an address book, people you're following, and then you pick one. You know the NPUB of the recipient already, and then you type in sats, and then you're good to go.
Okay. So I guess one other question related to that is, how do you know when you have been paid? So let's say, Burak, you generate your NPUB or your ARC public key. I sent you 2 million sats. How do you know you got paid?
Yeah, so I do, like, I know the recipient, I know the MPUB of the recipient, and then I add some ephemeral value to it. This ephemeral value is a random value, and because I tweak add, it obfuscates the dedicated address, right? The trace. It prevents the address reuse, because no one can tell what this public keys belong to, because I've just added a random value to it.
Yeah.
So it just looks like a random address on a protocol. You cannot associate it with the dedicated address, the intended recipient. And this ephemeral value, I send this ephemeral value, right, like a 32-byte string, along with some additional info, right? The payment value, payment amount, maybe some payment note, out of band to the intended recipient.
I see. And so I send you an out of band message to tell you, oh, hey, Burak, here's my payment for 2 million sats that I'm making through the ARC system. I guess this is kind of like Lightning has gossip and Lightning's, peer-to-peer layer where where the nodes are talking to each other. This is a similar kind of thing, but maybe it doesn't have to be through one particular way. I could have sent you that through, could it be through like an email or a Nostra DM or some other thing?
Yeah. Exactly. It can be out of band in any way, but it's going to be Nostra DM by default. We're going to use Nostra as a transport layer in this case. So you're going to receive a DM. A DM pops up on your DM, like a payment info, like a payment info. From the sender of the payment lets you know about the payment info, the ephemeral value, and the additional info. And you receive a DM, you go check the pull transaction, the coin join ID, right? Like the sender lets you know about your destination, the destination of your coins, the destination of your vTXOs, the transaction ID, the coin join transaction ID, and the output index of your vTXOs, and the ephemeral value in one DM, in one package, and you go check out the on-chain data, like when you're offline. So when you're back online, you realize you received a DM from someone, a friend, who claims that they send you a payment, say 500 sats, under this coin join transaction ID ABCXIZ, and your outpoint, the vTXO index is like 1235. And then you go check out on-chain data, you see that, okay, there is this transaction ID. It's legit. It exists. Confirmed like a while ago, like hours ago. And you go also check your outpoint index, the vault index of your coin, the vTXO, that it's also legit. Also, a few other validations. And then you say, okay, I see it.
Sorry, so can you just explain that part? How are you checking? So let's say you've received this, 500 sats. Where are you going to check that? Like, where is your wallet going to check that information to see, yes, I got the payment?
So you first check the transaction ID, right? The coin join transaction ID, it's like one input, like three output transaction on chain. You have that transaction in every 5 seconds. And the message in your DM contains the transaction ID. So you go check the ID. And then the message also tells you about the destination, the vault index of your vTXO, plus the whole content of the shared vTXO. It tells you the destination of your vTXO, but it also tells you about the rest of vTXOs, so that you can compute the root. The script pub key, recompute the script pub key of the shared vTXO based on the content of all vTXOs nests under that vTXO, shared vTXO. You do the computation and you see, okay, I see the whole content, right? There are hundreds of vTXOs under this shared vTXO. And here is my index is like 1235, right? Thousands of vTXOs, and here my index, 1235 index. I see it, right? I see it, it's there. I recomputed it. And I also see that, okay, this ephemeral value and my dedicated public key, when I civic add, it also match. It's a match, right? My vTXO index is a match. The script public key of my vTXO index is a match. It matches the tweak ephemeral value and my dedicated public key. And I also reconstruct the scripting, like the ATLC script and the vTXO script, so that, okay, this transaction exists. The whole content is available to me, the shared vTXO content, and I know what my vTXO, like vote ID is, and I see that it's legit. The scripting, the ATLC scripting and the vTXO scripting is legit. So this is a properly built payout. It's a proper payout. It's a legit payout.
Yeah.
And then I consider this payment, if it's confirmed, right, final. If it's not confirmed, if I'm online, I'm receiving, right, you have to wait a confirmation, on-chain confirmations, to consider it final, but it doesn't prevent you from spending it. Like, it is immediately available to you. The payment you receive, if it's not confirmed, it's in the mempool, it can in theory be double spent by the service provider, not the sender. It can be solely double spent by the service provider who created this transaction, the 1 in 3 out transaction, the coin join in the first place. It can in theory be double spent in the mempool level. Then that's why you have to wait for confirmations in theory. But it has immediate availability to you. The funds you receive in the mempool, vTXOs, they have immediate availability. Just like on-chain, just like how you can chain unconfirmed transactions on mempool, on Bitcoin, you can hand over vTXOs to others.
Gotcha. So I guess to explain that, so the point is you can immediately spend them forward, though theoretically it's possible that you kind of get rugged in terms of the mempool, like the ASP trying to double spend that coin. But as I understand from what I was reading in the dialogue and some of what you were saying, some of these ASPs might also be an LSP, as an example, and that you might have made that payment. Like, you might have received that, let's say I pay you 2 million sats on ARC, and you might you might be making a payment to some other guy, 1 million sats on Lightning or something like this. And at that point, the ASP has already sent out the Lightning payment, so they would be out their own money if they try to rug you, basically.
Rug you, And you already paid a Lightning invoice anyway. So in that case, again, because it has immediate availability, you can also pay Lightning invoices with it. Like, there's two types of transfers, like just like eCash. You can make internal transfers, eCash style, or you can pay Lightning invoices. And when you make a Lightning invoice with the entire money you're receiving to a Lightning vendor, you can consider it final. Although it's not confirmed, you already paid an invoice. You obtained the pre-image from the vendor. So it is a final payment. So ARC is a protocol with delayed finality, but immediate availability. Funds are immediately available to you. You can hand over to someone, you can pay invoices with them, but they are final at some point, after several confirmations.
So just to expand, or just so I can understand the finality versus settlement component, or availability versus settlement, I'm not sure the right term here, but as you were saying, it sounds like there's 5-second intervals. So basically on 5-second intervals, you could have been paid money. But in terms of considering that confirmed, we would wait until there's an on-chain confirmation, really, for there to be, like, in theory, final settlement, or at least on-chain, to the level that you consider an on-chain confirmation final, right? Yeah,
that's true. Funds are available to me after 5 seconds, but it's final after 10 minutes. So if I'm receiving payment, it's available. My balance is credited after 5 seconds once it's in a transaction, right? But it's confirmed. Once it's confirmed, it's final.
Gotcha. One other question there around the ASP side. So let's say it's on the ASP now to get that confirmation within 10 minutes. What if the block space fee market runs away from them? Like, they put this transaction in at 10 sats a byte and all of a sudden it rockets up to 50 sats a byte. Is it on the ASP now to do some kind of RBF or some kind of operation to make sure it confirms in the next block?
is ASP's burden and responsibility to make sure that pool transactions, the coin joins that they create, ends up in a block. It's their responsibility to do it.
Okay. So let's talk a little bit about the ASP side of this, right? So, can we just walk through a little bit what's involved from the ASP side? As I guess at a high level, I'm thinking, and from what I've read as well, it sounds like there will be, if we're calling them an ASP or ASP coordinator, that there will be a high capital requirement, right? That they need to have a lot of coin themselves in order to really run a proper ASP, because users might need it's kind of like it's like a similar thing to being an LSP today, that you need a lot of coins in order to be able to manage people's channels. It's a similar kind of thing, right? So could you just explain a little bit from the ASP point of view, what's going on?
Yeah, so it's very similar to LSPs. Like LSPs have a bunch of outgoing on inbound channels, right, to make sure that they provide a service properly for end users. It's similar in ASPs. Like you have to provide liquidity, a bunch of bunch of liquidity for the subsequent coin join sessions, right? Because you have a new coin join in every 5 seconds, and you need to have enough liquidity on hand, like on-chain funds available to you, so that you can provide liquidity for these coin joins. And you lock up funds for 4 weeks in every 5 seconds. So on an ongoing basis, you're constantly providing liquidity. And liquidity gets exhausted at some point. So you have to make sure that you have enough liquidity for the ongoing coin join transactions. And the liquidity you lock up, i.e. for 4 weeks, only be revealed to you, available to you after 4 weeks. So you have to make sure that you have enough liquidity to provide liquidity for a whole month, right?
I see. So it's kind of like you are basically not able to use those coins for 4 weeks, I guess, and because obviously this is a full reserve system, right? There's no fractional reserve here, right? So also in terms of getting stuff confirmed. Oh, sorry, I just forgot the question I had in my mind. But basically, in terms of getting stuff confirmed, it's kind of like sorry, that's the question. In terms of the ASPs, do they need to get a transaction confirmed into every block, or how does that work?
Yeah, so in theory, there could be just one transaction a block, right? In theory, that works. In fact, like a Wabi-Sabi, i.e., you have a coin join session in every 20 minutes, right? Like in every 2 blocks. Here we went a bit extreme, right? We have rapid coin joins because ORC is more of a scaling solution than a privacy protocol, and we have to optimize for the most optimal, the best mobile experience. Because coin joins are interactive by nature, it should ideally be done, and because we are making a payment in a coin join, right? Inherently, at the core of the protocol at its core, everything is a coin join, whether it's the payment or regular mixing. It's in a coin join. And if I'm an end user, right, if I'm using a non-interactive client such as a web wallet or a mobile wallet, it should be a seamless UX, and it shouldn't take it shouldn't take long for me to make a payment on ORC. Whether it's paying a Lightning invoice or making an internal transfer, everything is in a coin join. And if a coin join takes 10 minutes to complete, I have to wait 10 minutes on my smartphone to make a payment. So to optimize for the UX, the better UX, we have to make this compromise, right? There has to be a new coin join session in every 5 seconds so that we can bring the most optimal UX to end users. Okay,
so let me just summarize a little bit my understanding then. So the user is opting into this system. It's like he puts his vTXO in. Let's say I want to go into the system. I put 10 million sats in there, and inside the virtual TXO system, I've got this virtual 10 million sats. Now the ASP is helping me sort of manage that. And as you mentioned, there is this time locking or hash. What was the concept? TX lock. Sorry, the TX locking system. And what's going on is every 5 seconds there's a coin join round, and as a result of that, the ASP is having to make on-chain transactions to help confirm those, to provide the liquidity, right? And so as you were saying, go on.
They provide liquidity and they make sure that they're confirmed. because if it's not confirmed, it breaks the atomicity. If you want to ensure the atomicity, in order for an ASP to claim the sender's money, ASP has to make sure that the transaction is confirmed. The coin join transactions that they create, they end up in a Bitcoin block. And they provide liquidity for them, obviously.
And so the ASP has to really make sure. Now, of course, like we're saying, this is scaling. So the idea is there may be thousands of users, maybe hundreds of thousands of users, all with one ASP, and there would be multiple ASPs, right? And they can kind of, can they route to each other, or how does that part work?
Yeah, so they do not. There's ASPs on Arc. They're self-isolated with each other, so they're not quite they're not interoperable. They're not even aware of each other, and they don't have to. So Arc, like on Arc, you have ASPs. You can pick your own ASP. Like in the initial onboarding phase, you remember, like you peg in the protocol to a Bitcoin address, and the Bitcoin address is a 2 of 2. The client software you're using, the Arc client, whether it's a web client or mobile client, it gives you an on-chain Bitcoin address to peg in your funds, right, in the first place. And that address contains the 2 of the co-signer of your ASP of your choice. And that can be any ASP. Your client can pick it automatically or based on the fee market, right? It's a free market based on the fee rate they're offering, the service. You pick in the protocol into the ASP, right, the virtual set, and you can pick, whichever ASP you want. And from there, you're in the system, and from there, you can only transact through that ASP. You cannot transact through other ASPs, because the 2 of 2 between me and the ASP. In the subsequent runs, I have to join that particular ASP's coin join round. If that ASP blacklists me for some reason, and that also goes to LSPs, I can do a unilateral exit. I can trigger a unilateral exit, just like a forced closure on Lightning.
You can take your coins back without asking permission,
back on chain, and I can switch off my ASP to someone else. Could be a Frost Federation, could be someone else who is not blacklisting.
So in terms of the really frictionless payments aspect, the best case you're saying would be obviously if 2 people are part of the same ASP. But if you've got like one person on ASP A and another person on ASP B, there's not really an interoperability there. Maybe you would have those 2 ASPs have like lightning channels with each other, and maybe they would settle that way, or what are you thinking there?
You don't have to make them interoperable. So if I'm using ASP A, and the intended recipient, doesn't matter which ASP it uses. It can be it could be someone just on board the protocol, right? So let's say I'm Bob. There is Alice, right? And Charlie is the operator. I have a 2 of 2 between me and Charlie, right? Bob and Charlie. I have some vTXOs, let's say 1 mil sats, and then I want to send some sats to Alice, right? And Alice can use Dave as as her preferred ASP or not. It could be just onboard the protocol, right? And what happens is I join the coin join session with Charlie, the ASP. I'm Bob. And I join the coin join session to send Alice a mil sats in a coin join. And the coin join, the recipient is Alice, and the vTXO of Alice is also a 2 of 2 between Alice and Charlie, the ASP and Alice. So when that transaction confirms, Alice's client software realize Alice now has vTXO between her and her ASP, Charlie. And from the subsequent runs, i.e. to send someone, right? Alice joins the Charlie's coin join round to create another vTXO between the new intended recipient and the Charlie on an ongoing basis. If you're paying an invoice and you're connected to, you have vTXO set among different ASPs, say you use ASP ABC, XYZ, KLM, different ASPs, and you are paying a vendor a Lightning node, and you can pay it through you can pay a Lightning invoice, a single Lightning invoice via MPP style payout, so that you're forwarding HDLC, like you're pushing HDLCs in a coin join, right? Instead of attaching ATLCs like vTXOs, instead of registering for vTXOs in a coin join on the output registration phase, you register for HTLCs, and you attach them to your factory. Like you have like 3 service providers. You join them one by one to attach the HTLC. You attach 3 HTLCs. And from there, these 3 HTLCs, they're also running routers. They're also LSPs. And from there, they forward in-flight HTLCs to the end destination in a 1 MPP payout. But in the internal transfer case, it is a self-isolated payout. If I have like 3 coins, 1 mil each, one is between me and ASP ABC, the other one between me, ASP XYZ, and the third one between me, and ASP KLM.
So as I'm reading you, then the concept is you could have, let's say, one ARC wallet on your phone, as an example, and you could be connected to multiple ASPs, and there's nothing wrong with that. I mean, I guess it's like having a Lightning node, and you're connected to different channels, partners, right? It's kind of like
exactly.
that, right?
Like Lightning, you have like channels between different channel partners. You have a channel between you and XYZ. You have a channel between ABC, but it's interoperable because you can forward HTLCs in an MPP style like payout.
I see. Okay, and so if somebody is, I guess, put it this way, if somebody is not already a member of an ARC or with an ASP and you want to make a payment to them, you basically need to get them to set up with ARC, right? To set up an an ARC wallet and create an NPUB or use like their Nostra NPUB as an example and take a payment that way.
Not really. The recipient is not aware of anything, not even aware of the ASP that he's receiving from, right? The recipient just downloads a piece of software, right? And it makes their NPUB available to everyone else, i.e. adding to their Twitter tipping, right? The sender knows, all it takes is the sender knowing the NPUB of the
of course, of course. You just need to know the other guy's public key in this case. Yeah,
and then the recipient ends up having a DM, right? Telling him, you received the payment, and the payment is
that's the out-of-bound message to say, hey, you received the payment. Gotcha.
And then the message says you have a payment between you and ASP XYZ.
Okay, gotcha. So yeah, it's complicated, but it's like a whole new concept to learn. But I think I'm slowly understanding part of it. Probably misunderstanding other parts of it. But anyway, one other question: how do our ASPs profit? Do they charge a fee?
Yeah, ARC is a liquidity protocol just like Lightning, and the service providers, ARC service providers, they are like 3 things. They're liquidity providers, they're service providers, and service, I mean blinded coin join coordinators. They provide the coin join service, but they're also Lightning service providers. They're also Lightning routers. They have to provide liquidity to both ARC, but also Lightning. They have to make sure they have enough channels on Lightning, like to a broader protocol. And I also like giving this Lightning subnet analogy. Like ARC is more like a subnet of Lightning. It's like this end user subnet. You can internally do coin joins and all that. Like you can mix vTXOs. You can do internal transfers vTXOs with each other, with friends and family and all that, or even Nostra tipping, but you can forward HTLCs to broader Lightning. You can get paid from the broader Lightning, but internally at its core, it's a different sort of design. Internally, it's a rapid coin join protocol based on the shared vTXO model. Internally, it's different, but externally, it is interoperable with Lightning. You can pay invoices. You can get paid from invoices. So it is it's a distinct layer 2, but with Lightning interoperability.
Yeah. One other question around users refreshing their coins. So from reading the documents, it looks like the user needs to come online at least once every 4 weeks to stop the ASP basically being able to run away with the coins. So how does it work in terms of coming online to refresh? Yeah. Do you need to do an on-chain transaction for that refresh, or is it just like going online?
You do we call it remix. This is a cool term. So once you're in the system, once you peg in, and once you only pull it on chain when you peg in and peg out. For internal transfers, it's footprint minimal. They're all off-chain coin joins, right? I mean, there is the on-chain part of it, but it's minimal. 1 in, 3 out every 5 seconds. I consider it footprint minimal because it's minimal in size, the on-chain part. But off-chain part is the internal transfers or paying Lightning invoices. And your coins, your vTXOs, unlike on-chain, has an expiry. Like they expire at some point. In an on-chain wallet, unlike on-chain, they're infinitely there. You can do the cold storage or even hot, but they will be there forever, right? If they're not spent. On the Oric, your coins expires at some point, which I think this is not a trade-off at all. I'll come to that. So your coins expires after 4 weeks. So imagine you have a vTXO, but it expires, right? You have to spend it before it expires. Otherwise, it's gone. In the ARC context, so you have a coin, you send it to someone, the recipient receives it, and the recipient now has a 4-week time lock, right? 4-week time lock. After 4 weeks, it expires. So the intended recipient has to spend that vTXO in that time frame, 4-week time frame. And if it's about to expire, right, you haven't spent it yet. You're holding it. You're a holder. You want to hold Bitcoin on the ARC. You're not spending. And your vTXO is about to expire. What you do, you do a self-swap. You return your coins back to yourself.
It's like a self-send. Gotcha.
Self-send. You join a coin join session to send yourself to reset the 4-week timer. And this is called Remix. And Remix are not charged liquidity fees.
Gotcha. And this is like in the coin join protocols where they call remix. The idea is to get multiple mixes to give yourself additional privacy. So I guess it's kind of mimicking that idea, remixing.
Could be, yeah. So So if your coin is about to expire, you do Remix, and Remix are not charged liquidity fees.
I see. In terms of picking ASP, how do you see ASPs competing? Would you see that as like do they compete based on how much liquidity they have? Do they compete based on uptime, availability? Like, how would you pick one ASP versus another ASP?
I mean, you only pick your ASPs in the initial onboarding phase, as you remember. Like, you're not actually able to pick it like once you're in the system, because it's heavily reliant on who are you receiving from. If you're the sender, your friend, i.e., sending a payment or Zap or donation or whatever, using ASP XYZ, and you have a coin, a vTXO between you and XYZ. And you have to join XYZ session to send it forward the payment further, right? And you are subject to the fee policies that AXP XYZ charges, like dictates, right? You're subject to it. If you're not happy with the policy, the fee rates, which is totally customizable, like it's a free market. There will be many competing ASPs with different fee schedules, fee rates, and all that, both in terms of on-chain fees and liquidity fees, basis points. You are subject to their policy. Like, there is nothing you can do. It highly depends on what ASP the sender you're receiving from.
I guess
who the sender.
Right. So I guess worst case, you would try to withdraw out and take it back on-chain into your hardware wallet or your multi-sig or whatever, right?
Pay a Lightning invoice,
Or pay a Lightning invoice and get out that way, right? Yeah. Okay, gotcha. So so I guess even though we're talking about the protocols in a competitive way, like ARC versus Lightning and so on, you're also seeing it in a complementary way that some of these providers might be both, right? You might be both an ASP and an LSP, and then the user is sort of able to use both functions. And then it's on the ASP side to kind of manage their Lightning liquidity and Lightning channels and all those other aspects of it to give the user the better experience, right?
That's all about that's what org is all about. Yeah, giving their end users a frictionless, proper UX like payment experience in a sub-custodial way. And ASPs are they have to be ASPs. I mean, it's not quite optional, although it might seem optional. ASPs, they should be also ASPs. They also should provide.
So it's not optional. Okay, I didn't quite get that part. Yeah. Okay, thanks for clarifying that.
In theory it is, but in practice, no. Like you're using Org to pay Lightning invoices too, right? I mean, obviously. I designed Org, like that's how it all started. Org started as a Lightning wallet idea.
Gotcha.
And Org is a Lightning wallet. Like Org is like a subnet again. Org and Org wallet is a Lightning wallet. Org protocol
the subnet is a point. Subnet. Yeah. Okay. And so I guess I think we touched on this before, but I guess the idea is, let's say I have this one Arc wallet, and I've got maybe 3 or 4 different ASPs on there because I have coins with them, or vTXOs with them. I guess the idea is my wallet would need to periodically check to do that 4-week remix thing, right? To kind of periodically remix so that I don't lose my coins. So basically the idea is the wallet needs to come online every now and again, at least, to do that remixing, but it's doing it across multiple ASPs, not just one, right?
Yeah, that's true.
Gotcha.
That's true. Lightning has the similar assumption. In fact,
right, of course, yeah. With Lightning, you're checking all the channels, etc.
24/7. Yeah. Here it's more. It's more. It's just for weeks, but it's also. I don't see this as a trade-off because, like in extreme cases, like in a boat accident or some inheritance-related issues, if you lose your funds for some reason, you can just reach out to your LSP, your service provider, for a refund.
I see, yeah. And of course, I think the idea here is this would mainly be for spending amounts, right? Like we would still expect people who have like serious coin, they should be putting that in the hardware wallet or hardware signing device or multi-sig and stuff like that. And this is seen more like a spending wallet amount, right? Or no?
Like if you are seeking proper cold storage, yes, but you can also seek a cold storage if you are interested in storing your Bitcoin, like in a more secure way, like on Org, because if you're concerned about on-chain fees and all that, you can do it on Org too, with customizable like custom pools with custom custom expiring pools.
Right. So instead of the 4-week expiry, it could be extended.
Like, 1 week, like 1 year, it could be 2 years.
Gotcha.
Obviously, you're being charged more fees for that because the liquidity allocation requirements are higher, right? ASP has to provide like lock their liquidity for 1 year, or 5 months, right? In that case, you're being charged more fees ideally. But if you're seeking a storage, like storing your Bitcoin without dealing with all this interactivity, i.e. for 6 months, 1 year, you can do it in theory, yes, with an LSP of your choice. An ASP can provide that service for you, a custom pools with custom pools. I mean, coin join transactions with custom CLTV deltas.
I see. Okay, so let's talk a little bit about some of the criticisms I've seen as well. One of the criticisms I've seen is this idea of, I guess it's kind of like a vaporware criticism, or this idea of, you're putting out all this idea, but where's the working code? Where's the software? I'm curious if you have any thoughts on that as well.
Oh, yeah. So there is, I love this saying, like, cyberpunks write code, wizards craft magic. So I'm not a cyberpunk, I'm a wizard. I craft magic. I like designing stuff. I like protocol design and all that. And in fact, I do not qualify myself as software engineer, although I did some software engineering stuff in the past. Like I did some mobile development, I did some Bitcoin development, but I really don't think I fall into that category. I'm not quite a software engineer myself. I'm more like I'm more like a wizard, right? That's I think the right category for me. And I speak with my experience, right? I did like a 2 years long Covenant research and development on Liquid, and based on my experience, that's how Arc started, right? Arc has evolved from a Lightning Vault idea, and it's based on my experience and knowledge and Covenants. And I have been obsessed with Lightning scaling and privacy. And that's how Arc started in the first place. And I speak with my experience, yes. Arc is an idea. It is in the early protocol iteration phase, yes. It's gonna take a long time, yes. We're gonna do some prototyping. I'm currently assembling a team of Bitcoin, like an Avengers team of Bitcoin engineers and devs. We are aiming to be able to help ship like a prototype, like a primitive version, hopefully Q3 this year, later this year. We're trying to figure out like where to do prototyping first. Should it be like a Signet or Inquisition, or should it be mainnet? Like interactive version of mainnet, because like there's like 2 different versions we can do, like interactive mainnet versus like non-interactive.
Gotcha. That was the other question I was going to ask. Can you explain a little bit about the interactive version versus the non-interactive version of this? So as I understand, the non-interactive version requires APO, any prove out, or check template verify, or some other alternatives that basically give us covenants, or it's going to be an interactive protocol. So could you explain the differences there for us?
Yeah, so Orc is something we can build on Bitcoin today, but we have to compromise on non-interactivity to do so. We can build an interactive version of Orc, just like Lightning, just like how you self-host a Lightning node, LND, or LDK node. You can self-host your Orc clan, a hypothetical Orc clan, Orc daemon, CLI, on your Umbrella, or a Raspberry Pi, or could be on a server. You can self-host it. You're online, and you can receive payments. You can send payments. The receiving part is why you have to be online, because if we don't have covenants, we can use the only way to emulate covenants. Covenants, I mean restricting the transaction outputs of a spending transaction using N of N multisig. We can use N of N multisig to emulate covenants behavior, and that requires you to be online as a recipient to sign from the N of N shared vTXO to constrain your own portion of your virtual vTXO, among others, from the N of N to be online. So you have to be online to do so.
Right, and that's just like with Lightning today, that you need to be online to receive, etc.
Just like Lightning, yes. In theory, you can be offline on Lightning too, but you cannot receive. Part of the reason is you cannot create pre-images when you're offline. But PTLC solved that, really. But you have to be online anyway to cyber channel breaches. In org, you also have to be online in every few weeks. But you really have to be online to receive payments if we are here to build org on Bitcoin today. If we have covenants, however, such as CTV, TXS, CSVS cat. There are a bunch of different combinations you can do. If you have covenants on Bitcoin, it becomes non-interactive. You don't have to be online. You have to self-host. Simply, the shared vTXO is constrained to a set of transaction outputs containing your vTXO. And you can be offline, you can be on the go, you can receive it. You don't have to receive in that case. But I'm just dreaming, right? At this point. So we're trying to figure it out, right? Should we do an Inquisition, because Inquisition has CTV and APO. It's a Signet with experimental features, but Liquid also has covenants, right? And Liquid is in fact more like a Signet with actual Bitcoin value, right? So it might make sense, right? It might make more sense to do on Liquid if you are to do a non-interactive version.
It might help prove out the demand for CTV or APO, right? So that might be interesting to sort of show, oh, hey, there's actually a working use case here. But in terms of real world usage, it's probably going to be, that would be a slower path, but it would be interesting, at least from that perspective, to sort of show demand for that particular soft fork, whether it's APO or something. So I guess we should probably just quickly explain a little bit about covenants for people who are unfamiliar with that. I guess, let me just offer my kind of poor man or layman's explanation, and you tell me where I'm getting it wrong, all right? So I guess setting the context a little bit, because I understand people can get a bit concerned about covenants. So let me explain how I'm seeing it. So in Bitcoin today, we have time locking and we have multi-signature, which are types of smart contracts. But they restrict what you can spend in terms of already existing outputs. The idea with covenants is more like, what can you restrain in terms of future outputs? What is the future output of that transaction and what is the way that it can be spent, right? It's like a future restraint. And I understand where some people have a concern because, okay, does that lead to, could there be a risk where the government says, oh, you may only, transact inside the purview of the government or the state or with KYC, etc. But I think the important point to understand here is that it would be like an opt-in system, right? So for example, if you are generating an address to get paid today, you are the one determining whether it's a covenant or not. You are the one who's saying, I'm generating an address that's single signature that I can unilaterally control without a government, without anyone else, or without a third party. Or if you are opting into a covenant system, you would be the one to generate that, like an address or, some kind of covenant-based thing on which future restraints could be placed. And it sort of works as part of this system, as we've been talking about with Arc, and with even there might be improvements with Lightning as well. Who knows? So that's how I'm seeing it. How do you see it?
I 100% agree. We're on line with this. We're on the same page here, like on the same table. Yeah. So covenants is a way to constrain spending the outputs of a spending transaction of a future transaction. Versus today, you cannot really constrain the future transaction. Here on Arc, covenants are obviously entirely opt-in, so you already know in advance that you're part of the covenant script. So you are part of the covenant, an output you're spending, right, in the next transaction. You're already part of the covenant. You know it. You know in advance that you're part of the covenant. You already opt in to covenant. And in terms of the blacklist censoring stuff state level, well, it's also possible to do on Bitcoin today, like with multisig. Multisig, a state could be a co-signer of the multisig, and you can do it on Bitcoin in a policy level. Well, covenants do it, and Kim might do it in a protocol level, in interpreter level, but it's already possible on Bitcoin today. And it's entirely opt-in, and I don't really understand why people are so scared of it. It's just a very simple primitive. It unlocks a bunch of use cases, and it's entirely opt-in, and you can do it at all sort of blacklisting evil stuff on Bitcoin today too with multisigs.
Yeah, so I think the main thing is really fear of the unknown, and it's another whole technical concept that people aren't familiar with, right? Whereas people today are familiar with the concept of multi-signature, they're familiar with the concept of time locking. It's used as part of Lightning today, CSV, check sequence verify. So I think it's just that people aren't comfortable with that, and I think this is part of the educational journey that everyone has to go on. And in fairness, I think what happened with Jeremy, with CTV, with check template verify, I think a lot of people, people got spooked a bit. People got a bit scared because of the activation attempt when I think at the time it was really only developer and kind of insider circles who really knew what that was. And I think there were a lot of people who were just sort of instinctively saying, whoa, hold on, what's this? Like, I don't want people to change Bitcoin. I don't want to change things. And this is where there may be some tension, right, on that aspect of whether Bitcoin should have a soft fork, because there will be all these arguments coming up about, well, if we don't have soft forks in Bitcoin, will that mean a lot of people end up custodial and more people end up custodial than otherwise? Because, without having these covenants and these kind of extra features and things like CTV and any prov out and maybe opvault and things like this that maybe scale the self-custody element of it. I guess that's how I'm viewing that anyway. But what do you think?
Yeah, we have to do more job on educating people. Yeah, people for some reason are scared of it, especially for the recursive covenant stuff. Though CTV doesn't enable recursive covenants, and in fact, I'm in favor of recursive covenants too. But yeah, we have to do more, a better job on, communicating with the community better on this, like covenant, educating them. The trade-offs, always, there is a trade-off everywhere, right? You're changing Bitcoin, it could be risks involved. But covenants they are there on Liquid, like already. It's been there for years. And you could think of Liquid as a test bed. And I did some work on Liquid in the past. And from what I can tell based on my experience, it's entirely opt-in and it's entirely secure. Like, you can do this all evil use cases on mainnet too on today, and it unlocks a bunch of use cases, and let's bring them. And in fact, I'm seeing, and I appreciate it. Like, I was in favor of CTV activation at the time. I was on a pro CTV camp, And I appreciate like the people who were against it, because culturally in Bitcoin we tend to preserve the protocol, and this is the way to go. I appreciate it a lot, but I'm seeing like people changing ideas, shifting their ideas, and like getting I see more and more people day after day, week after week, in favor of getting in favor of on CTV and covenants in general. So hopefully, yeah. We're seeing the trends. Yes, hopefully we'll get there at some point.
Yeah. A few other smaller criticisms or ideas that I've heard in relation to ARC, and maybe some of these also apply to Lightning, in fairness, but this idea of if a lot of people all unilaterally exit at once, does this create a rushing to the exits problem? And I guess just one thing to add to that before you answer, I think this is a point Laolu also made, or Roast Beef. He was saying if everything has to unroll, the amounts still have to be economical relative to the chain fees, right? So do you have any thoughts on that idea?
Yeah, so the former concern, right? If everyone rushes out for an exit, like on-chain mempools, it would be a disaster. Yes, that trade-off also goes to Lightning. But I have a design in my mind that can address this further. Like in the long term, it's like more like a long-term feature extension thing. So Arc, how Arc today, like the way I design it, in my head. I mean, obviously, I'm working on the specs. That's what I'll be working on in the next few months. The way how it works is like if something goes wrong, you trigger a unilateral exit. But before doing that, you have to reveal all nested like vTXOs from the shared vTXO. You have to reveal them from the shared vTXO all in one. And that's how it works. But a feature extension of this will be hopefully a withdrawal tree. In a withdrawal tree, like tap, leave, update, verify style. So you have a bunch of vTXOs in a tree, and you can withdraw vTXOs from that tree one by one. And once you withdraw it, like a vTXO from the tree, we are adding like a relative lock time in addition to an absolute lock time, the absolute lock time being the end of 4 week, right? But also adding a relative lock time, i.e. at 24 hours to this tree, so that whenever someone withdraws a vTXO from the tree, the 24-hour timer resets back to 0, and the remainder, like the other vTXOs in the tree, remains. So that although the 4-week timer is over, it could take years, decades to withdraw from the shared vTXO in a disaster scenario. In that case, this is because every time 24-hour resets to 0, right? This is theoretically possible in Bitcoin. Like we can do it today, even like without covenants in theory, because again, we can emulate CTV with N of N. But even with CTV or TXH alone, it is really hard. Like because we don't have top, leaf, update, verify, right? And without that, we can emulate it with CTV or TXH can emulate a withdrawal tree, tap, leaf, update, verify style withdrawal trees.
Okay. So with the withdrawal tree, is the idea then that you're staggering the exits?
Yeah, the sweep closure, like the ASP, the service provider sweeping it got delayed every time, by 24 hours.
Okay.
Every time someone withdraws from the tree.
Okay. Yeah, gotcha. Okay, cool. So I think those are probably the key questions. I mean, I'm sure there's like 1,000 rabbit holes we could explore, but I'm trying to keep the episode manageable for people. Hopefully this is a good overview. We've gone through a lot. So I guess let me just kind of summarize again, just so people are sort of trying to get their hands around it at least. So the idea is this is an off-chain protocol. The idea is the user can opt into this ASP as an example. They can lift his UTXO. The ASP helps him manage that, and there's ATLCs, and there's all this technical stuff in the background to sort of make it atomic, right? To make it, and so that he can unilaterally exit. But the long and the short of it is that he can essentially peg in some coins into ARC, let's say. He has a vTXO. Those vTXOs can be traded around very frictionlessly, and because there's a 5-second round, every round there's a remix. The ASP is managing that. The ASP has a lot of liquidity and capital costs, but the ASP is also an LSP and it's managing all of these aspects. And in terms of the user being able to exit unilaterally, he can still do that And the way payments would work is basically you would need to know the other guy's public key, his ARC public key, I guess. And then you can just make payments without the inbound liquidity problem, which is what we have today in Lightning. So it seems the main downsides, though, are to do it in the best case, it requires a soft fork to get some kind of covenant. And the other big downside is it seems like the ASPs require it's a very high capital cost, because the ASP has to have enough Bitcoin to basically back or kind of bankroll all the transactions going on inside their ASP for 4 weeks.
Perfect.
Fair summary?
Yeah, that sounds everything well. Yeah, but it's a great one. Thank you.
Okay, great.
I couldn't have described better yet, to be honest.
Okay, well, there you go. All right. So we'll see what other feedback people have. Are there other criticisms and other ideas people have out there? Of course, everyone, leave your comments in the in the Twitter threads or on YouTube or whatever. Burak, where can people find you if they want to follow you and find out more about all of this stuff?
Yeah. So you can find me out on Twitter. My handle is BRQGOO, or Burak in short. It's a quite a unique name in the Bitcoin space. But we also have a Telegram group, like our community group on Telegram. You can find it out on Telegram, ARC community, or we also have a website called arcpil.me. So on the website, we have a brief one-pager overview, a protocol overview, plus a deep dive if you're technical enough and interested in learning more. Also, we have a short, we also have a FAQ if you have any further questions. We also have a get involved page. On that page, you can find a link to our Telegram channel, and feel free to join our channel if you have any questions or of any kind. Really, it could be stupid or not. Feel free to join and ask any questions you might have. And if you want to donate, we have an on-chain address. And if you are a Bitcoin talent, if you're a Rust talent, feel free to reach out to us. On the get email page, we have like email from which you can reach out to us if you want to contribute, and if you're a Bitcoin talent.
Fantastic. Okay, well, thank you. I hope it's a very optimistic vision of what an alternative L2 could offer to Bitcoin. So thanks for joining me and helping explain this, as well as being gracious about the criticisms also. Thanks for joining me.
Yeah, thanks for having me.
Get the show notes at stephanlivera.com/482. And if you enjoyed this one, make sure to share it so other people can learn also. Thanks for listening, and I'll see you in the Citadels.